Hello, and welcome to our ACEDS webinar, How the New AI-Based Analytics Ignite a Productivity Revolution in eDiscovery. Our webinar is sponsored by our affiliate ZyLAB, and it's an educational webinar that will use as examples some slides and some screenshots. We have a wonderful panel here, and we've got two of the leading experts in AI, and particularly AI as applied to legal. We have Johannes Scholtes, otherwise known as Jan. He's the Chairman and Chief Strategy Officer of my alma mater, ZyLAB. Before joining ZyLAB, Jan was a lieutenant in the Intelligence Department of the Royal Dutch Navy. His degrees include Master of Science in Computer Science from Delft and a PhD in Computational Linguistics from the University of Amsterdam. And since 2008, almost 10 years, he's been the Extraordinary Chair in Text Mining from the Department of Knowledge Engineering at the University of Maastricht. And his students, he does put his students through their paces, and their projects are just absolutely stunning. You may see some of them in the webinar. We also have, to complement Jan, Paul Starrett. He's an attorney, a private investigator. His business is Starrett Consulting, and he's the rare attorney that is also a programmer. He programs Python, and he co-organized the PyBay, San Francisco's largest Python conference, and that is no small feat to put together an organization around programming when you have that JD, Paul. He's also a certified fraud examiner, NK certified, and he's the current chair of the Big Data Committee of the American Bar Association. And Paul and I had a conversation it was a couple of years ago, and he was thinking about going back to school to get a master's in some of the newer technology, and he did it. He's got a Master of Science in Predictive Analytics from Northwestern University, and he focused in unstructured data clustering and classification, something that is near and dear to all of our hearts. So we're going to take a look at AI. What is AI? What is analytics? And you can see that there will be many, many different topics here in the webinar. As always, we will provide you the slides after the webinar. The recording will be available, and we're very, very interested in what you want to know. So at the bottom of your screen is the Q&A tab. You can hit that and then ask your question. We won't read your name out unless you write in your question you want your name read out. So it'll be anonymous, and you can ask whatever it is you'd like. And then today we will be looking at, here is the agenda. We'll be looking at the tools from the fields of artificial intelligence and data science. And Jan and Paul are both very, very skilled in what you would call truth-finding missions or fact-finding missions, the investigatory aspect of eDiscovery, in addition to the moving of the haystacks of larger big data trying to get down to a small set. So they'll be talking about that, some of the new AI-based analytics that have increased in speed, and then how does it compare? There are a lot of different verticals that are in approaches to AI in other areas like an Amazon or a Netflix and things of that. So how does it compare? And so to start us off, Paul, can you talk a little bit about AI and, should we be afraid of the robots? Are they going to take over all the lawyer jobs? Tell us a little bit about that.
Yeah, and to be honest, I haven't been deeply immersed in that, but I have had enough exposure to machine learning and artificial intelligence to come to the conclusion that I don't think the technologies are really close enough. In fact, really not at all, to be fearful now. Because and I'll get into some of this later, but I don't think so. And I think some of the fear is that at some point that artificial intelligence might be able to write contracts for clients, or might be able to do review in the case of, and they are kind of here with predictive coding. But I think overall, it's really it takes what's in place already and moves it forward. The analogy I like to use is, if you had to get from the West Coast to the East Coast, would you drive a car or would you fly an airplane? Well, clearly you'd fly an airplane, budgets notwithstanding. So it's really, to look at this, I think, is a net gain, is that it really enables things, and I think we'll get to that a little bit later. So with that, I think I'll just take the rein here and go on to the next slide. And I think really, to start us off here, get an idea of what we're actually talking about from a high level. Analytics is sort of the typical use of data science in ways that help us as humans understand what's in our data. And a lot of it's very familiar to us. We use clustering, we use timeline review, text mining. There's actually an area of technology that, in my exposure to Python, called search engineering. There's an actual title called search engineer. So there are many tools, machine learning, data mining, that are available to inform us as humans about what's going on with our case. And they leverage math, basically, to help us do that. So that's where analytics is key. Artificial intelligence is really more the use of some of the tools. There is some conceptual overlap with analytics, but it's more the use of certain types of data. I think we find most that natural language and text comes up a lot, because that's how humans think, especially when they're communicating electronically. And so it's really it's using artificial intelligence to help us leverage how we think and how we can use that technology to advance what we do. I thought it was interesting, Jan, how you came up with this definition in the middle on the right-hand side.
Yeah, absolutely. No, what we're doing right now at the Legal Tech Professional Institute, the LTPI, is that we're actually defining a taxonomy of different fields of different areas that the field of artificial intelligence covers. And we try to use this to bring a little bit order in the chaos of the artificial intelligence hype that's currently going as a storm to the legal community. And what we see is that artificial intelligence is a very broad and complex field of research that has been around since the 50s, even though many of you may not know that. And we've been trying to mimic human intelligence even since John von Neumann built the first computers. And a lot of what we're doing today also with deep learning has been done many, many years before. I wrote a blog about that also actually recently on my LinkedIn profile. And what we see is that we're trying to cover areas such as reasoning, problem solving, knowledge representation, planning, which are not always of direct interest of the legal community. But on the other hand, you see areas like machine learning, natural language processing, perception, which are very much in the interest of the legal community. And then there's a lot of other areas like motion, robotics, social intelligence, and even creativity, where you get more towards the Hollywood type of artificial intelligence. Now, all of these are fields of artificial intelligence, and what we are going to talk about today are in particular the machine learning, natural language processing, and perception. Back to you, Paul.
Yeah, we have our first question. Human teaming, so-called centaurs, are most likely future in other industries rather than robots replacing humans, and how might this emerge in eDiscovery or contract review? Paul, do you have a thought on that?
I'm not familiar with that term. I mean, if I had to think about something that is sort of operating on its own, again, I would revert back to my own understanding of where artificial intelligence is. I mean, it's really, I think there's certain groups, universities, and maybe some of what Jan has done, that are very deeply involved in research, but there's still quite a bit left to be done in order to, autonomous vehicles is an area I get involved in occasionally, just as self-interest. And there's so many factors. I think we're too far off. So that would be my contribution to that.
Well, I'm not familiar with the term centaurs myself as well, but if this means that humans and computers are teaming up to get the best possible performance, that's actually what we do see, what I truly believe in, where computers are doing the boring type of work, what they're very good at, very fast processing of text and numbers, and then humans are there to do the more creative, intelligent, quality type of control, common sense part of the decision making. And that's where we see that many of our the projects that I'm involved in, computers can do things often like many times faster than humans. They do them more accurately and more cost effective, and they work 24/7. And by doing that and preparing the work and preparing the data for the end users who can then take very quickly intelligent decisions, that's really the optimal way of having computers and humans work together, and that's how artificial intelligence can be the most productive.
Yeah, I mean, and just to finish that off, there are commercial applications out there, but I think they're well shy of what I think the person who asked the question is thinking. I'm guessing, you have commercial applications for contract management that use the simple forms of AI, and other similar things. So anyway, so I just to continue with the slide here, I think the definition that's copied here was actually generated by Jan's team from a collection of documents. So anyway, just to keep the pace here, the usual suspects. Data keeps exploding. Obviously, 90% of the data the statistics I've heard, 90% of the information that we're going to be using in a case is electronic, and of that, 80% is unstructured. And the other complex factor of that is that with the sort of the increase of the use of mobile devices and how those are paired with cloud computing has added a whole new spectrum of data that we now have to accommodate. So it's getting more complex, it's getting larger. And the other thing that I would note from this particular slide is that it used to be that before you thought about using data science solutions, you thought, oh, that's just a problem with the Fortune 100. That actually is dropping down in what's called the middle market, the Fortune 2, 3, 4, 5,000. So this is becoming a bigger problem for everyone, and data science is being used more often than not, or should be. It also includes things that are sort of similar to eDiscovery, regulations, the General Data Protection Act regulation, if I said that correctly, which next year goes into effect in May of 2018, which has some ominous penalties, but does have requirements for handling large amounts of data, and artificial intelligence solutions are being brought to bear there as well. Consistent with that is these sort of zealous regulators who are, for antitrust actions and for other regulations, they make huge demands, and that again really encourages use of every tool that's possible. So with regard to the eDiscovery data wave, I really think the overarching concept here is predictability. Clients or people who have a case, they don't like deadline overruns, they don't like cost overruns, deadline slips and cost overruns. So what I used to do back when I was in my heyday of electronic discovery in 2006 to 2010, when the economy was tanking, there were tons of lawsuits, as we all know. And what I would do is get every single team member on the phone at the outset, both from the eDiscovery vendor, the outside counsel, and the enterprise, and get them all on the phone at the same time, so that when you you're able to pin down the legal issues, the priorities, what's the value of the case, what costs are realistic, and then from there, that tells you what data that you're going to need. And once you get into that realm of things, you start to get into what's the data wave, essentially. And that's where you want to be very keen on when and where and how you can apply artificial intelligence, because again, it's only going to make it much more efficient and cost effective in what you do. And so that's sort of the eDiscovery side of it. On the analytics side, I think that the concept with Analytics is that we are leveraging technologies that help us understand the data, because any predictive model you're going to use, any artificial intelligence, is no better than the data that you give it. It learns from what you find. So as an investigator, the way I see this, and the way I see sort of the upstream aspect of review, is to use whatever tools you have available to you. Analytics, there's document clustering, there's regular expression searches, there are all kinds of tools. But the idea is to leverage these analytical tools to remove documents, to find where you can save money, and above all, to understand what's going on with your case, so that when you're ready to start setting up deadlines and budgets, and you're ready for your meet and confer and so forth, you are very well educated on the underlying principles and the data that you've got and what you're going to have to do with it. And why artificial intelligence-based analytics? Well, there are many reasons that that I could cite, but I think the most important thing is that it's kind of like having a butler. You know, if you wanted someone to do something for you, wouldn't you want that? That's kind of what this is. It really makes life easier. It makes it more efficient. It makes it more cost-effective, and it shrinks timelines. And the idea is that you're leveraging human cognitive capabilities to help you do that, so that as the artificial intelligence approach you use is informed by your prior investigation, you're able to just increase everything exponentially at times. And then the other question then becomes, well, is this something that is legally defensible? Well, the work done by Maura Grossman and Gordon Cormack, extensive work done, has been caught on with the courts. And obviously data science, which is used in flying airplanes and predicting the weather, why not have it used in our profession? And certainly the courts caught on to that. And as long as it's used properly, it's defensible, and it's something you can venture into with some comfort. This slide here, I think, is kind of points up the fact that human beings are kind of they're not, you know, they're subject to bias. They get tired. They go to coffee breaks. They forget things. But with machines, provided they're trained properly, that doesn't happen. So I think that it's kind of an interesting twist on the where we are with AI and humans. And what kind of analytics have we seen? I think this is really sort of a stack. And when I think about analytics at the outset, I'm thinking every single file or record is generated by a software solution. And they're done for a particular reason. So they generate certain metadata, they generate certain content around whatever their solution they're trying to provide, whether it's email or machine data. And from that information, you can build analytics that help you understand what's going on. So, for example, in email, you can do email threading. You can do link analysis. You can do timeline visualizations. You can see where things happen, so you can get the who, what, when, where, why, and how. In Python programming language, for example, and in ZyLAB's platform, there are tools that accommodate this to help you bring it all together, and it really tells a great story of the data tells and gets you to the truth quickly. With regard to the meaning of the data, that's, as we said, artificial intelligence tends to mimic humans' thinking, and often that involves text. And as people may or may not know, text and terms are categorical variables. They don't fit into equations. You can't say an apple plus a doorknob equals a Toyota Corolla. That's silly. But you can use numeric aspects of categorical variables, words or terms. Their frequency, how often do they appear in a document or across a document collection, how far apart are they from each other, how densely packed are they, does one word follow another, do 2 or 3 words always show up together? So we use those metrics as a means of creating tools that will help you identify, for example, sentiment in a document or emotion and other things. So it helps you sort of get into the meaning of the data and build from there. And then finally, with machine learning, based on what you've learned up to that point, you can classify. When you say predict in the categorical variable, that is to say text, you're talking about classification. Prediction in the categorical variable area is called classification. Is a document relevant or not? Is something belong to a certain topic or not? So this is sort of the stack and the way in which you go about building up to an artificial intelligence solution. And then here on this last slide, where I'm going to kind of leave, I'm going to cover the content on the right-hand side, and this, frankly, I think is one of the more important slides in this presentation. Again, you see the focus of the two topic, the topic modeling and the natural language processing, and that's not a mystery, because again, that's where we find how we think. There's one thing I'd like to point out, and why you want to try and leverage tools that companies like ZyLAB have created. I'll give you a quick example. I have a colleague who's in legal ethics, and his name is Solan Barakas, and he told me about an effort that was done by some scientists. They had thousands of images of dogs and of wolves. They wanted to see if their predictive model could tell the difference between wolves and dogs. Well, it turns out it was very, very effective. And they were using convolutional neural network, which you see listed here. And what that is it has an input, it has an output, it has a hidden layer in the middle. What that hidden layer does is it looks for values that help it make that prediction. And it will just keep going and going and going until it finds that set of values. Often it goes unnoticed by the human. So back to the dog and wolf issue, what they found was that the neural network had picked up on the snow that was behind the wolves in the pictures, because pictures of wolves generally come from the wild, and that's why the snow was there. So it picked up on the snow in the pictures as a way of delineating dogs from wolves, and they didn't know that. So you really have to understand your data. You really have to, before you start getting carried away, you really want to pay attention to what's going on. And just one final note, I'm an investigator. I don't tend to spend as much time in eDiscovery anymore. I like to use tools like decision trees and hierarchical clustering and things like that that are very, very detailed. And I use that as a way of helping build models that can be used. And there's a process in that. But I can't tell you how important that is to have that knowledge. I think with that, I'm going to pass it over to Jan, who's going to cover the left side of the slide and then continue on.
Yeah, Paul, thank you. Thank you very much. Yeah, that was a very good example of the wolves and the dogs, and that's what we call in neural networks or convolutional neural networks the attribution problem. You never know which neuron is responsible for which part of the decision process, and that makes neural networks or deep learning a little bit scary. And that's also one of the reasons why people are scared of it. Also, a lot of famous people that write all the articles about that we should be careful about artificial intelligence. And you're absolutely right that when you're using decision trees, it's much more explicit how the knowledge is represented and which parts of the knowledge that's represented and stored is responsible for which part of the decision. And that's where we have to be very careful, especially in the legal space where everything has to be defensible. We should not present artificial intelligence as black boxes or magic, because that's not going to fly. People are not going to accept that. So we have to explain artificial intelligence in a very clear and transparent way. And we also have to make sure that if we do use techniques like deep learning or convolutional neural networks, that we do find ways to prevent that certain things decisions are made based on information that actually is not correct, or based on parameters or features that are not the features that are really the ones that are important. Now, looking at all these artificial intelligence techniques, and we are also in the process of preparing an ebook of this. And if you go to our website, there is already an ebook on TAR, where we also explain in depth what some of these algorithms do, like NMF, which is non-negative matrix factorization, which is a very powerful algorithm for topic modeling and concept search. And we actually explain in the ebook why it's much better than LDA and LSI. And we also explain the same for the differences between support vector machines and deep learning and decision trees. So if you're more interested in some backgrounds and benefits of the algorithms, you should definitely download the ebook, or get the ebook, the new ebook on artificial intelligence and analytics once it's ready. Now, going from these artificial intelligence algorithms and all the tools that artificial intelligence has given us over the years, you can look at the left side of this slide where there are the eDiscovery needs. So what does eDiscovery or the legal community need? Now, in eDiscovery in particular, there's technology or tools related to our human perception that we need. We need reading tools, and you may not know it, but in 1987, artificial intelligence or optical character recognition was considered to be a form of artificial intelligence. Ray Kurzweil, the visionary writer of The Singularity is Near, he is also the father of the OCR engines. He's also the inventor of the Kurzweil machine, which is used by people that have reading disabilities. Handwriting detection, signature detection, all once were considered to be artificial intelligence. Now, that's one of the things with artificial intelligence. Once we understand it, it's no longer, and we know how it works, and we can solve a problem, then it's no longer considered to be artificial intelligence in general. But audio search, as we have it these days, listening, the ability to deal with audio, vision, the ability to deal with images, and I'll give you a couple of examples. Language, different languages in particular, machine translation, but also intelligent search, where I will show you a couple of examples which include not only machine learning for search, but also, of course, the concept clustering and the automatic alignment of data along typical investigative questions, such as Paul already said, like who, where, when, what, why, how, and how much. And then finally, TAR, which is in fact nothing more than text classification, or to be more accurate, document classification, where you're going to classify documents as being responsive or not responsive. We've seen a lot of success recently in contract analysis, where paragraphs or clauses are automatically being detected and classified, and by the ability to classify sentences or phrases, it's even possible to do a very high level of privileged detection in documents. Now, all of these different tools, I will show you a couple of examples from. Now, to start with, the audio search. This is an example as we have it in our software, where we can search directly on the sound files, on the MP3 files or WAV files. You key in some text, the text is converted into phonemes. The phonemes are matched against the phonemes recognized in the text, and you can immediately jump to areas in the text file where you can see what somebody said. The text is not transcribed. It's just an ability to search in sound and listen to the sound. This is all done by using techniques from the artificial intelligence. It uses deep learning. It uses statistical pattern recognition. And maybe in a couple of years from now, we can also have very, very highly accurate transcription of text. It's a little bit harder because for transcription of text, you need to have all the words that you want to be able to transcribe in a dictionary, which is not always possible. So, but searching is actually very accurate and very high quality. Another example of human perception is machine translation, which we have integrated in our platform so that we can automatically translate text from Chinese or Japanese, as I'm showing on this slide. And then instead of having to translate all documents first, you can just look at the translations. That again here, a warning that translations are not legally submissible, but at least as a reviewer, you get an idea of what's in there. And if you believe it could be responsive or relevant, or maybe even a hot document, then you can always have the translation being checked or cleaned up by a human translator. One of the more relevant types of perception is also the detection of handwriting, and in contract analysis, of course, also the ability to find if a document has been signed and whose signature it was, and was that person authorized to sign. Now, you may ask yourself, why is handwriting interesting? Now, the right slide of this, right image of this slide here, what you see is the invitation of a banquet from 1995 in the hope of resolving the peace in Bosnia-Herzegovina, and this was a dinner organized where the different parties were invited. And what you see here on this slide is actually some drawing which was done by Milosevic, where he actually proposed how to split up the city of I forgot the name there, of Sarajevo, sorry, between the Serbs and the Croatians, which he discussed at the dinner. Now, by being able to just detect documents which contain some handwriting, you can not only find these type of documents, but you can also find the document on the left side, which was used from the tobacco data set, where you can actually see some notes. Please keep this information confidential, which has been written by somebody on a document, and this can be very, very important for true finding missions. Okay, another more modern or more relevant type of perception is visual classification of images. With the upcoming GDPR, there's going to be even more necessary to detect personal identifiable information or protected health information. But also a lot of typical legal documents like plaintiffs can be recognized by their layout and how they look like. And it's very easy for computers to learn to recognize IDs or passports or screenshots or even WhatsApp type of images. Now, you may ask yourself, why is that relevant? Now, what we see is that especially in fraud cases or regulatory violations, more and more people are communicating by using different channels like Snapchat or WhatsApp. And it's very hard to obtain text from those files. Snapchats are being deleted automatically and WhatsApp is highly encrypted. So what they do in many cases in order to remember things or to also protect themselves, just in case something may not go the way they envision it, is that they screenshot these type of images. Now, by recognizing these images and by OCRing the content, you can, and actually the same is this is an example of somebody who had a message on WhatsApp on his watch and then make a picture with his camera, with his phone. We see more and more of this type of data in investigations and especially in regulatory investigations. Now, the next one is an example which is another example which we see a lot in regulatory investigations, where fraudsters try to hide information, not by encrypting it, because that's often considered to be a red flag, but by embedding information in objects. You can embed a TIFF or a JPEG or another image in an Excel file or in a Word file, or you can hide an email in a calendar item. Now, unless you unpack every individual object and make it searchable, you will never find that information. And this is what we call structural analysis. Structural analysis looks also at metadata. Very interesting metadata is metadata which is related to the structure of the email communication. Is it like one person broadcasting to a whole group, or is it one-on-one, or is it one-on-one with somebody's private email? Is it somebody forwarding it to his private email? Those type of communications are often the most interesting for investigators. And that's another example of structural one-on-one communication that we show here. And the most famous one that everybody, of course, is using these days is the analysis of email threads, where you can immediately see which emails you have not collected, which are missing, either because you haven't collected a particular custodian or because somebody may have deleted those emails. And again, that's another example of structural analytics. Now, moving to the more conceptual analytics, this is where we see semantic analysis. This is where the computer recognizes company names or individual names or locations or amounts or those type of things. It's looking more to meaning of documents. It's also very well possible to recognize emotions and sentiments, which are always very interesting in an e-discovery or investigative type context, because this is where things don't go as expected, and this is the location where you can often find very interesting information on the modus operandi of fraudsters, or on finding out what really happened or who took certain decisions. Now, where artificial intelligence has really helped us is if you want to find something and you don't really know what you're looking for. And that's where clustering and hierarchical clustering in particular, and this word wheel shows topic modeling, can be very beneficial, where you take a totally unstructured approach and just take a lot of data. This is actually some data from a very large data set, 800,000 documents from Reuters. And then you build these type of hierarchical clusters, which will help you to kind of identify which are interesting topics. And then by looking up or drilling down into these topics, you can then build machine learning classifiers based on the most dominant documents containing these topics. Now, all of this is part of a larger plan, a larger vision that we have at ZyLAB, is where we are doing a lot of efforts to organize unstructured data along typical investigative dimensions, like who is it, what is it, when is it, where, why, how much. And depending on what type of investigation you're doing, the who's and the where's and the when's can be a little different. The who's could be persons, or it could be your competitors, or it could be other semantic entities. And then you can look at those in different relationships. You can look at word wheels, which typically indicate what happened. Or you can look at relations between persons or companies or other individuals, which will give you community networks and community detection capabilities. You can look at timelines. You can do geo-mapping. And what we find most interesting, and I've told about this in my previous ASETS webinars as well, is more detailed insights where we combine these different questions. So who did what with who did something why, where the who's and the why's, the who's can be represented by the names from the individuals that you automatically detect, and the why's can be often recognized as part of certain emotions that were present in text. Or what happened when, which what we are currently developing is what we call topic rivers, which allow one to do a topic modeling, but then in time, and you can see the changes over time. Now, that's where ultimately we want to be, but where we already are and what we already can do is very, very accurate and easy and very high recall with machine learning. And this has been an approach we've been using a lot in the recent months, and actually year, where we used machine learning classifiers based on certain documents and certain documents that investigators found, or lawyers reviewed a large document set, they found like 100 relevant documents, and we use those 100 relevant documents to train a classifier, and then we map it against the rest of the data set, and then in all cases we will find more relevant documents than the lawyers originally did, which is very consistent to the research that was also done by many people in the field of eDiscovery, who show consistently that computers find more relevant data than humans. Now, I've tried to explain that in this picture here, where on the left side you see the traditional search tools that investigators can use, from standard search to metadata search to more advanced search like fuzzy search or regular expression search, or you do search as a result of advanced processing, deep processing, such as the additional OCR or bitmaps or audio search. And then, at the end of the day, investigators who manage and control and understand all these different query types, they will be able to get very high, 80% on average, highest recall. And then if they want to go up, they can use machine learning. Now, you can also take a different approach, where you start using the machine learning already after a very simple Boolean or metadata search, and then use those documents to find the other 60%, as I've indicated it here in this graph, almost automatically by using the machine learning. And this is where we see we have a great deal of success, not only for document classification, to find responsive documents and to boost recall, but also to measure recall, because by using these techniques, you can very accurately tell the other party or the judge or the regulator what the percentage of documents is that you've probably found. But we're bringing this now down to the paragraph classification level, where we're no longer looking at documents as a whole, but we're going to look inside documents, which creates all kinds of huge problems, because suddenly you have an enormous explosion of possible text entities that you need to classify. But this is very interesting for privilege review or document clause classification or contract clause classification, and also for GDPR, the General Data Protection Regulation, where very, very soon, whenever you have data that originates from Europe and a U.S. regulator, or it's being requested in a U.S. eDiscovery case, this data needs to be pseudonymized or needs to be redacted, and you don't want to do this manually, because doing this manually will be very, very expensive. Now, what is the interesting thing is to measure the recall. There are different ways to how you can very accurately measure the recall of a certain machine learning or search or investigation, and not only by using precision and recall, or F values, or 11 points precision recall, as the specialists in the webinar are probably aware of, but also by looking at the return set of the documents that are returned. And we've seen, again, not only that these type of search operations are much faster and much more cost effective. Typically, we do it in 15 to 20 times faster than human beings. But also, we see that in almost every case, they find at least 20% more documents. And in some cases, we find even like up to 50% more relevant documents, which is a huge difference between manual review and computer review. And this, especially with data sets being millions or tens of millions, sometimes even 100 millions of documents, it's impossible to review those by human beings, especially since human beings are adaptive, cognitive creatures that learn as they do it. So they change their insights, they change their decision process. So one of the biggest problems we see in the review of these large document sets is the inconsistency of tagging over time during such a project. And that's something which you will not have with computers. Computers will always operate in the same way. They're very autistic devices, and so they were very, very consistent. And if they do something wrong, it is very easy to fix it, because they have made the same consistent error over and over again. Where humans make all kinds of different creative errors, and especially in large reviews, this results in absolute chaos. So Printless review, you can do it, of course, by using metadata, but you can also do it by redacting information. But before you can redact it or pseudonymize it, you need to identify it first, and that's where this type of machine learning can be very beneficial. The most popular application right now of this type of machine learning on the paragraph or clause or sentence level is in contract analysis, where contracts are taught to recognize change of control or different types of indemnification, liability clauses, termination clauses. Most of these algorithms are very reliable, and depending on what mechanism you use, you can actually have less or more insight. But this is something that is absolutely a very successful application of artificial intelligence and analytics in the legal space. Now, what do we see as the benefits to, for instance, if you're in-house counsel? You can see that the direct collection of platforms such as we have them makes it very easy to get data. You don't have to ship around disks and download and upload all kind of risky operations. The deep processing, that the very deep analytics or the very advanced structural analytics will allow you to make every component of the data searchable. And if the data component is searchable, you can then use automatic tools to cull it. And a great example here is in Microsoft Office 365. You're using their tools for eDiscovery. If a component is not searchable or not every component part of the document is searchable, it will be automatically passed through to the review process, which will automatically add enormous amounts of non-searchable, documents where you have no understanding of the content. The review accelerators, they speak for themselves. Star, sampling, redaction, automatic redaction. They take a lot of cost out of the most expensive and time-consuming part for the eDiscovery. And then, of course, the early case assessment, where analytics are most useful in the beginning of the process, allow you to make proper decisions in time based on facts and help you to select the best strategy that you can use in your case. So, Paul, you want to add something to this, or you want to move it to the law firms?
I think you covered it well. I think the law firms, we can move to that, and I covered that briefly just to keep the pace going here. Right.
So and we have a question, Paul. Why do you think TAR isn't being used more often? The questioner sees a lot of linear manual review after a simple keyword search only. Is it the cost, do you think?
Well, that's an interesting question. I think some people they're not comfortable with what they don't understand what's going on under the hood. I think some of them. I think if you're using a tool that's like ZyLAB, where that's all been kind of built in, that shouldn't be an issue. I think that's one major reason. People they're not used to breaking their habits, which they should do, of course. If you ask me. But the other thing is, I think that sometimes the predictive models, they do things quicker. They take away billable hours for attorneys, and that's not the right way to look at it, because the firm down the street that's doing it quicker and more cheaply is going to get the business next time. So I think those are the issues that I find.
Well, that brings you into your the slide here, the benefits to law firms for using these types of AI.
Right, and I'll just approach this very briefly. I think really that the key thing here is that it's all in-house. You have everything under one roof. One of the problems I saw was that when you go from one provider to another, things get lost in the shuffle, and that's risky. So whether it's data or someone doesn't know, someone did something, one aspect of processing or culling, and they don't pass that information along to the next outsourced provider, you lose things, and that's risky. So when you have everything under one roof, that goes away. And you're able to really stay focused on each part of the process and make sure that it's all sewn together properly. It's also the learning curve is lessened because everyone's using the same tool that's in the law firm. You don't have that problem with having to relearn some new tool. And I think that probably one of the most important things is that you are able to make sure that you're getting all the issues that you need. Because the worst thing you can do as a law firm is not pick up on an important issue that's an issue of substantive value in your case. So if you have control over everything, you're able to make sure that all of the gears fit together and run properly, and you're able to use tools that really drill down and find out what's going on in your data. You're increasing the chance that, one, you're going to win your case. Two, if there's a problem, you're going to call it out quickly and act out accordingly. And then, of course, you lower the risk of having issues with your client. So I think that would be a great way of summarizing the slide.
Yeah. No, and I fully agree with that. And to answer your question, Mary, yes, TAR was very expensive in the past, but these days TAR is included. It's included for free in our platform, and we've made it very, very simple to use it. And I think there's really no reason why you should not use TAR as part of the whole eDiscovery process. The amounts of data are getting so large that you will be able to bill your hours anyway as a law firm, and the data amounts are still doubling every 18 months, or even faster, some people believe. And on the other hand, if you are able, as Paul said, to pick up on problems faster, you can act faster. You can provide your client with valuable strategic legal advice, which at the end of the day, that's what will bring you more business, not like very large linear review projects with contract attorneys.
Excellent, because AI certainly was the buzz at ILTA, and we have a couple of other questions. Paul, can you identify some standalone tools that you use for AI, and then Jan, as a follow-up, some of the tools you and your students use as well. We've got some questions from folks wondering about those things.
Yeah, this is Paul. First of all, if I have a tool like ZyLAB, I would use that first. To have to build that myself would be not worth the time at all. But I'm a big Python fan. I have focused there almost exclusively. I don't use R, which is another language I played with. I don't like it. But Python, if you're willing to go through the process, it's straightforward but not easy, Python. But you can do almost anything with Python. That would be one thing. There are other the Apache tools, Apache project, apache.org, all open source. You have search engines and some other, clustering and graph databases and some other things there. So that would be my answer.
Yeah. Yeah, what we see a lot and what we recommend our clients a lot is that the data is in our platform, and we have pulled everything together pulled everything apart, and we've identified each individual component, and we added text everywhere, and we extracted metadata. Then there are two tools which are very easy to use by connecting them directly to our database. One is Microsoft Power BI. It's a great analytics tool that allows you to do all kinds of analytics, time-based analytics, immunity detection, etc. It's free. You can download an individual copy free of charge, and then you can link it to the databases that we generate. So you don't have to worry about all the basic stuff, and then the problem of non-searchable PDFs or embedded emails or embedded images. And then you can use it for early case assessment. The other tool is Gephi. It's an open source free product, which is a great tool if you want to do advanced community detection. And it has all kinds of clustering and data visualization tools in it. And that's what I use almost all the time with my students.
Excellent. Thank you. And if people want to want to see your platform, Jan, how would they go about contacting you?
Yeah. Well, if you want to have a demo, let us know, and we'll give you a demo very soon. You can also try it yourself. So if you're interested in a do-it-yourself demo, let us know, and we will send you a link as soon as we have this demo ready and available. And then you can search yourself. You can play with it. We have uploaded the entire annual data set, and we will also set up a possibility where you can upload your own data, and then we will automatically process it, and you can then see how fast and quickly it can be analyzed for early case assessment and review and production in our product. One of the things that we're very proud of at ZyLAB is that we know that all the lawyers, except for Paul and Mary maybe, are not like technicians. So we try to make it easy. We try to provide lawyers with comfort by using advanced technology. So we don't make it harder than it already is, and we got a lot of quotes there. If you want to see how we do it before going to a demo, go to our website. We have a lot of ebooks. And they're about handling regulatory requests. They're about technology-assisted review. We have ebooks on GDPR, and very shortly we will also have an ebook diving more deeply into artificial intelligence-based webinars. And then more information can be found on our website. And we also have several other webinars the rest of this calendar year, including these type of educational webinars, but also more practical webinars where we show particular features of our software, including integrations with Microsoft Office 365. So that's it. Mary, back to you.
Well, thank you. And Paul, do you have any closing comments?
I really don't. I just think that it's important for people to self-learn about the technologies that they're using. As Jan suggested, you can go to his site and learn things, or whatever, YouTube, whatever you can do to learn. If you're using the technology, you should understand how it's used, and then you should be able to explain how it's used. So that would be, I think, definitely the one thing I'd close on.
Yeah, and I want to underscore that because there's a lot of discussion in our community as to what is AI, what is TAR, what is predictive coding, and people use different definitions of all of these things. So to be up on that for your own conversations, and then certainly if you're in a buying role, so that or a selling role, so that you know that you're communicating on the same wavelength. I think that's going to be very, very important for all of us. In addition to the material that Jan's got and the upcoming webinars, we also have a webinar coming up next week for Ask the Expert. It's on careers. We'll probably have some poll questions on AI and how people are handling AI. If you're interested in that, that's a pretty freewheeling webinar, totally listener driven with questions, and that's next Thursday. Let's see, we've got a question about getting the slides and the recording, and we definitely will send a communication out so that you will have those, and we'll post those on our website. So I want to thank you, Paul, for bringing your expertise to the table, and Jan, your expertise, and ZyLAB sponsoring this wonderful webinar for our community. I want to thank everybody who spent some of their summer day listening to AI and analytics, and we look forward to seeing you on our next webinar. Thank you.
Thank you. Bye-bye.
Thank you.